In this video, let's go ahead and practice evaluating and working with some function notation together. For questions 1 through 4, let's go ahead and start by evaluating some of these functions given the value of x. We're going to make sure we also go ahead and show detailed and logical work to go along with our answers. So you can see here that we have 3 different functions. We have f of x, we have g of x, and we have h of x, just 3 different named functions here. And let's see, for number 1, we're going to find f of negative 2. So that really just means that x is going to be negative 2, and we're going to use this f of x function over here. So all right, so we can see here that we're plugging in negative 2 in for x here, right? So we're going to go ahead and use our function of f of x and say it's going to be 4 multiplied by this negative 2. Go ahead and substitute that in, and then go ahead and take away 8 afterwards. Now, let's go ahead and just use the order of operations. 4 times negative 2 is going to be negative 8. We have negative 8 minus 8, and that's going to be equal to negative 16. So f of negative 2 is going to be equal to negative 16 for number 1. For number 2, let's see, we have h of 5, so we're going to go ahead and look at our h of x function here, but our x value is going to be 5. So let's go ahead and plug in 5 in for x here, but we're going to make sure we use that h of x function, so we're going to say it's going to be negative 3 multiplied by, let's go ahead and plug in 5 in for x, and then go ahead and take away 4. Now, negative 3 times 5 is going to be negative 15. And then negative 15 minus this 4 here is going to be negative 19. So h of 5, or when x is 5, the h of x function is going to be equal to negative 19. For number 3, we have a couple of functions here. We have g of 7 plus f of 2. So let's see, we're going to go ahead and take the g function and go ahead and plug in 7 into this function over here. And then we're going to take the 2 and plug that into the f of x function and add those two answers together. So let's start with g of 7. So let's see here. G of 7, so here is our g of x function. We're changing x to 7 here. Go ahead and plugging this in. We're going to have, I'm going to use brackets just to kind of separate these first, okay? So I'm going to have negative 2. Now to keep things nice and organized, let's go ahead and use brackets to maybe organize this information. So we have g of x, that's going to be negative 1/2 multiplied by, we're saying x is going to be 7. So go ahead and plug in 7 in for x, then plus 3. And let's see, we're going to go ahead and add on f of 2. So go ahead and write what f of 2 is going to be. We have our f of x function here, and x is going to be 2. So it's going to be 4 multiplied by, we'll put a 2 in for x here, and then take away 8. All right, make sure you evaluate each of these functions separately and then add those answers together afterwards. All right, so let's go ahead and take care of this. In our first function here, negative 1/2 times 7 is going to be negative 3.5. So I'm going to write negative 3.5 plus 3. I'm going to keep this in our first set of brackets. And then what about our second one? Well, if we go ahead and take this 4 times 2, that's going to be 8. So we're going to have 8 minus 8. Now for this first function here for g of x, negative 3.5 plus 3 is going to be negative 1/2. And then for our second function here for our f of 2, 8 minus 8 is just going to be 0. So negative 1/2 plus 0 is going to be equal to negative 1/2. So that would be the value of if you had x equaling 7 and x equaling 2 in these two different functions, and then adding those two answers together. Oh, I forgot to make this 2 over here red earlier, so I'll go ahead and do that now. Here we're going to be using negative 3 for that h function and 4 for that g function, right? So let's go ahead and plug that in for the h function. Let's see here. It's going to be negative 3 multiplied by this negative 3. All right, and then we're going to go ahead and take away 4. And let's see, we're going to go ahead and take away g of 4. Now g of 4, let's go ahead and put this in brackets as well. That's going to be negative 1/2 multiplied by 4 here. Go ahead and put that in parentheses, multiplied by 4, and then we're going to go ahead and add 3. All right, so that would be our original expression here. Let's go ahead and now evaluate it. I'm going to go ahead and multiply these first bits from both of these sets of brackets. So negative 3 times negative 3 is going to be positive 9. So we have 9 minus 4 for this h function here. And then for the g function, we're going to have negative 1/2 times 4 is going to be negative 2. So we have negative 2 plus 3. Okay, 9 minus 4 is going to be 5. And then negative 2 plus 3 is going to be 1. So we have 5 minus 1, and that's going to be equal to 4. All right, cool. Let's check out 5 through 8. In these problems over here, 5 through 8, we're going to go ahead and use each of these functions to determine the value of x, a little different than what we were just doing. We were just finding the value of the functions. Now we're going to go ahead and find the values of x. Let's go ahead and make sure we show detailed and logical work as well. All right, so for number 5, we have g of x, that's equal to -8. Notice that we have a few different functions here, but we're going to be using this g of x function for number 5 specifically. So if g of x is equal to -8, let's go ahead and change g of x and substitute in -8 there. So I'm going to say this is going to be -8 is equal to, and then we have 1/3 of x minus 2. Now let's go ahead and solve this using just two-step equations here, right? So let's go ahead and add 2 to both sides of this equation. If we go ahead and add 2 to both sides here, on the left side we're going to get -6, and on the right side we're going to have 1/3 of x. And then let's see, on both sides of the equation, we can go to multiply the right side by 3 and multiply the left side by 3 as well. Use the multiplicative inverses. If we do that, we're going to get -18 is equal to 1x, or just equal to x here. So this would be the value of x if g of x was equal to -8. So we can go ahead and write our solution here and say that g of -18, if x was -18, we would get this -8 value here. So this would be our answer. What about number 6? For number 6, we see here that we have the f of x is equal to -7. So we're going to use our f of x function here. Now f of x is equal to -7, so plugging in -7 here for f of x, that's going to be equal to -x and then plus 4. This is another two-step equation here. Let's go ahead and use the subtraction property of equality and take away 4 from both sides of the equation. If we do that, we're going to get -11 on the left side is equal to -x plus 0 on the right side. Just use the identity property of addition and drop that 0. Then you can divide both sides by -1 or multiply both sides by -1, your choice. I'm going to go ahead and multiply both sides by -1 here. And then we're going to get +11 is equal to +1x, or we can say x is equal to 11. So what we found out here is that if you take f of 11, if 11 goes in for x for the f function, we're going to get -7 out. That's what we just found out. This would be our solution. For number 7, we have h of x is equal to 17. So we're going to go ahead and use this h of x function right over here. We know h of x is 17. We're going to find out the x value where that happens, right? So we have 17 is equal to -2x plus 5. All right, so we have a two-step equation, just like the last couple examples here. Let's go ahead and take away 5 from both sides here. If we go ahead and do so, 17 minus 5 is going to be 12. So 12 is equal to -2x. And let's go ahead and divide both sides by -2. And if we do that, we're going to see that -6 is equal to 1x, or just x here. So what we just found out here is that if you do h of -6, or when -6 goes into that h function, we're going to get 17 out, which is what the information was that we were given. All right, then for number 8, we have g of x is equal to 5. So here's g of x, and here is that function over here. So now we're going to say that g of x is equal to 5. So plugging in 5 in for g of x, we're going to say 5 is equal to 1/3 of x minus 2. So this is kind of similar to number 5, using the same function, just a different output here of 5. We're going to go ahead and find the input. So let's start by adding 2 to both sides here. If we add 2, 5 plus 2 is going to be 7. So we have 7 is equal to 1/3 x. And then you can go ahead and divide both sides by 1/3, or you can use the multiplicative inverse here, multiply both sides by 3, your choice. If we go ahead and do that, on the left side, 7 times 3 is 21. And on the right side, we're going to get 1x, or just x. What we just found out here is that g of 21, or the input of 21 into that g function, gets us the output of 5. This would be our answer. So for questions 9 through 15, they're all going to be linked together. So it looks like we have 4 tanks of water. We have tank A, tank B, tank C, and tank D, okay? Now tank A, the amount of water in it is being represented by this A of T. For the tank B, we have B of T, looks like we have C of T and D of T. So all of these we have are these functions in function notation letting us know how much water is left in the tank. And then T represents the amount of time measured in minutes for each of these scenarios, okay? So you can read through and pause if you need to. But if we take a look at question 9, the question says, which tank started out with more water between tank A and tank B? So let's go ahead and look at the difference between those two. Well, if we look at tank A has this information where we see that the equation here, the function is A of T is 200 plus 8T. And then if we go ahead and take a look at tank B, this one starts out with 400 gallons, but then is going to be decreasing at a rate of 5 gallons per minute. So we actually don't even have a function for this one yet. So we have our A of T function, but what about our B of T function? Maybe for this B of T function, we can go ahead and say B of T. Let's go ahead and write it so it's more clear. Let's say it's starting out with 400 gallons, so I'm going to write 400, but then it's decreasing, so we're going to take away 5 gallons per every minute. So I'm going to say minus 5t. So we're really going to go ahead and compare this a of t function with this b of t function. This a of t function you can see is adding water over time, where it's increasing because we have a plus at, but this b of t function is decreasing in the amount of water in it because it's minus 5t. So look at the coefficients there. Positive coefficient for t means it is increasing in water, and a negative coefficient for t let us know that the water level is decreasing. On the flip side here, we can also take a look at the constant terms of these functions. These constant terms let us know how much water there was when t is equal to 0, right? If you plug in t is equal to 0 for each of these functions, you're going to be left with a of t is equal to, or a of 0 is 200, and then b of 0 is 400. So that's going to be the starting amount of water before any time has gone by. So when the question for number 9 says which of these tanks starts out with more water, you would just look at the constant terms here. You would compare the 200 and the 400. So let's see, what are we going to go ahead and say? I'm going to go ahead and say here that tank B started with more. And the reason we can go ahead and say this is because the constant term of 400 is greater than 200. Something along the lines of that would be good. Now for number 10, we're being asked to go ahead and find a function to represent the relationship between b of t and t. Technically, I think we just went ahead and did that already here, so I'm actually just going to go ahead and copy and paste that and put that right over here since we already wrote that. Hopefully that makes sense. For this b of t function, we're starting out with 400 gallons of water, and then we're losing 5 gallons per minute. And then that is telling us, this b of t is saying how much water is there currently given a specific time value, or t value. Now for number 10, we're being asked to write an equation or a function here representing the relationship between b of t and t, which I think we already did earlier when we were just kind of looking at the situation. So let's go ahead and just copy and paste this. We'll take this right over here, and let's just go ahead and copy and paste that right over here. Remember, this b of t is how much water is there currently given a specific time value. And then we have the starting amount of 400 gallons, and then it was decreasing at a rate of 5 gallons for every minute. So this function hopefully makes sense in representing the current water levels for tank B. For number 11, it says consider tank A and B. So let's go ahead and look at A and B again. One tank is filling up and one tank is draining out or losing water. Which is which, and how can you tell between these two? Well, now I did mention this a little bit ago. If we try to look at those two equations again, or functions rather, our a of t function and our b of t function, they said one is gaining water and one is losing water. If you look at the coefficients for the t variable term here, these will let you know what is happening with the water level. So because we have a positive coefficient here, positive 8, that means it's gaining 8 gallons for every minute. And then for this b of t function, we have a negative 5 as a coefficient for t. The negative means that we are draining water out, or the water level is decreasing over time. So you really have to look at the coefficients here. So let's go ahead and see what can we write for our answer here. We can go here and say that tank A is going to be increasing. And we can also say that tank B is decreasing. In terms of how can we tell, we know that tank A is going to be increasing because it has a positive coefficient. For the variable of t. And we know that tank B is decreasing over time because we have a negative coefficient for t. What about number 12? For number 12, it's asking us about tank C. So it's saying, is it filling up or is it draining out? Maybe we can find out by looking at these coefficients. Let's go ahead and see what we know about C here. So for this third one, for tank C, it looks like we have this function here, c of t is equal to 800 minus 7t. So ask yourself, what does this 800 mean? And if you think that it means that it's a starting amount of water, you are correct. And what about this minus 7t or negative 7t? What does that represent? Well, that represents that the water is being drained out, or the water level is decreasing at 7 gallons per minute. So that negative coefficient lets us know that it's decreasing over time. So let's go ahead and take a look and answer this question. And we can go ahead and say that tank C is draining out or decreasing. I'll actually write draining out this time. In terms of how can we tell, we can say the negative 7 as a coefficient for T lets us know the water level is decreasing. All right, let's take a look at number 13. For question 13, we're being asked about tank D. So for tank D, we're going to be looking at this graph over here. We're not actually given an equation or any numbers of a particular sort here. So let's see if we can figure out what's going on with tank D. Keep in mind that for this tank D, we also have this D, capital D over here. So we're going to call this D of T. And so they basically just mean the same thing here, okay? Now, again, we don't have any specific numbers on this graph, but we can see here that if T was equal to 0 here, we have a starting amount of water. What happens as we keep going to the right here, as T becomes larger and larger and larger along that T axis or X axis, we can see here that the water level seems to be decreasing over time here, right? So you can see that as time goes on, it looks like the water level is decreasing until a certain amount of time we run out of water here. So if we're looking at this graph, I think it's safe to assume that tank D is draining out. We know this because we can see here as T increases, D of T decreases. All right, what about for question 14? For 14, we're going to be comparing tank B and tank C. It says which tank is draining out faster, and then how do we know? Well, let's see. We're looking at B and C. So for B, we have this function right over here, and for C, we have this function over here. It looks like C starts out with a lot more water here, right? C is starting out with 800 gallons, B is starting out with 400 gallons, but they're both losing water because of these negative coefficients here. But which one's losing water at a faster rate? This means this negative 5 means that it's losing at 5 per minute. That's for tank B. And this negative 7 means that this tank is losing at 7 per minute. So that's what that negative 7 represents for function C here. So function C is going to be losing faster because it has a greater coefficient here, or a greater absolute value, I guess you could say. So we can go ahead and say here that tank C is draining faster because the absolute value of negative 7 is going to be greater than the absolute value of negative 5. So if you basically compare those two coefficients, 7 is greater than 5, which means it's going to be a rate that is faster. And just because it is negative doesn't mean that it's lesser than. It's actually more of a decrease at a faster rate relative to the other one at negative 5. If you want, you can go ahead and say that negative 7t is a faster rate than negative 5t. All right, one final question here for question 15. It says, suppose tank D started out with more water than tank B, but less water than tank C. Okay, the water is draining from tank D at a faster rate than tank B, but a slower rate than tank C. What's a possible function? So we're going to come up with a function here for the graph of the function for this tank D over time. So let's see here. For this D function here, let's go to the right. It's going to be D of T. And let's see, how are we going to construct this function here? So let's start off with one piece at a time. Let's start off with the part where it talks about what its starting amount was. So let's see, it starts out with more water than tank B, but less water than tank C. So more than B, but less than C. So more than B, so B starts with 400, but it's got to be less than 800. So any starting amount between 400 and 800 is going to work. I'm going to start with 750. So I'm going to go ahead and write 750 here. I think that's perfectly fine as long as we're between 400 and 800. And then the other part here is that we know that it's going to be draining out faster. It's going to be faster than B, but it's going to be slower than C. So it's got to be faster than B, but slower than C. Let's look at those two functions here. So for B, here's its rate. And for C, let's see, the rate is -7. So I guess an easy number to use is -6 here. That's in between them. But I'm going to go with negative, I don't know, let's say -5.7. I'm going to go with minus 5.7 T. I'm basically saying it's going to be losing 5.7 gallons for every minute. Now keep in mind this is just one possible answer. Really, as long as you chose a number here that was going to be between, what do we say, 400 and 800. So as long as we say here, this had to be greater than 400 but less than 800, right? And then as long as for this coefficient here, we said it was going to be greater than -7 but had to be less than -5, we would have been fine with a coefficient there that was between those two numbers as well. Alright, so there you have 15 different practice problems dealing with some functions and function notation. Hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.